the second version of the function, and I would like to find the domain and range of this given function and its inverse. Okay, so this is restricted to the value of x that's greater than or equal to 0. It means that if you're going to visualize it, the graph of this, let's say it starts from 2, and it's going to be like that because it's not possible for x to be negative because x is greater than or equal to 0. So that means our domain is restricted to x is greater than or equal to 0, and our range will then be restricted to y is greater than or equal to 2. So that will be the domain and range of the function. In any case, this will be the graph of the function. I'm not going to show you yet inverse, but it's there. So because it is being restricted. Okay. Now, what about the range, the inverse? How do we find the domain and range of the inverse? So first is we flip our x and y, and then we will solve for y. So minus 2 on both sides of the equation, making it x minus 2 equals y squared. So therefore, all right, I will take the square root of both sides of the equation, but I'm not going to take the negative. Now remember, we are being restricted that our range here, y is greater than 2, and our domain is x is greater than or equal to 0. So therefore, this will also be restricted. So I cannot take the negative of this because the value of your x cannot be negative. These cannot be negative. So therefore, I would just take the positive square root of x minus 2. Now, looking at the analysis of the graph of the equation, it shows that our domain here is x is greater than or equal to 2 because when it comes to finding domain and range, it is just substituting any values of x in such a way that the value of y can only be a real number. 1 cannot be the value of x here because 1 minus 2 is negative 1, and the square root of negative 1 is not a real value. We only want y to be a real value in any value of x that I will plug in for the function. Therefore, since our domain is restricted to only values of x that are greater than or equal to 2, it means that the minimum value of y here is 0 because 2 minus 2 is 0 and the square root of 0 is 0. And remember that 0 is a real value and it goes to positive infinity. So therefore, the value of y is greater than or equal to 0. We can also write it as 2 to positive infinity and 0 to positive infinity. Now notice that if you're going to observe the domain and range of the functions, you would see that even the domain and range are flipped. Remember that the definition of inverse functions are just the flip values of x and y, and even the domain and range will be flipped then. So therefore, by conclusion, if you are asked to find the domain and range of the inverse of the function, all you have to do is to flip the domain and range of the function itself. So you have here, x is greater than 0 is your domain. It becomes the range of the inverse provided it's actually for y. Here, y is greater than or equal to, but here it becomes your domain. Okay. You would see that. Okay, these are the inverse functions of our given function. You would see that our y here is restricted to 0, okay, and our x is restricted to 2. All right, same thing here. Our x here is restricted to 0 and our y is restricted to 2. And if you will do the line of symmetry here, it shows that the two graphs are symmetrical of each other. Of a radical function. So, of course, if we graph this, we can find the domain and range easily. So the domain is all x is greater than or equal to 2.5, and the range will be y is greater than or equal to 0. But we also need to know how to do it algebraically. So y equals the square root of 2x minus 5. This number here cannot be negative. So therefore, the minimum value of this would be 0. So we could say that 2x minus 5 is greater than or equal to 0. And solving for x, you would solve that x is greater than or equal to 5 over 2. Or we can also put it as 2.5. Now this will be serving as our domain, that our x can be greater than or equal to 2.5 or can be written as 2.5 to positive infinity. Okay, we can only express the range logically based from the function itself. As you can see, the minimum value of x here is 2.5 and making also the minimum value of y to 0. Because if the least value is 2.5, 2.5 times 2 is 5 minus 5 is 0. That would be the minimum value of 0 of y, which is equivalent to 0. It cannot be negative, but it can be greater than 0. So therefore, the range would be y is greater than or equal to 0 or from 0 to positive infinity. It now follows that our inverse function, okay, has a domain of x is greater than or equal to 0 because there are inverse functions, so we do this as our domain, and our range would be y is greater than or equal to 2.5. Now we need to verify if that is really the case. So we will solve for the inverse function of our function. So we have to flip x and y. So you have x is equal to the square root of 2y minus 5. We free to 2y by raising the whole function to 2. And so you have x squared is equal to 2y minus 5. Okay, so we add both sides of the equation by 5. It will follow that x squared plus 5 is equal to 2y. And so our inverse function, I will write it here, okay, is equal to x squared over 2 plus 5 over 2, since we will divide the whole equation by 2. So this is now our inverse function. Now, how is it possible that our domain specifically here is x is greater than or equal to 0? Now, remember, we don't qualify a restriction here. X here can either be positive or negative. It can be positive 2, it can be negative 2. So I would be presuming that our domain here could be all real values of x. But remember, these are inverse function. They should be symmetrical to the line y equals x. If I'm going to include the values of x to the left of the graph, it will follow. I'm going to show you the graph. Okay? It will follow that, let's say, I'm not going to restrict it, this, all right? This doesn't look like an inverse function. I want the functions to be one-to-one, like here. So we cannot include this value here. So x here cannot be less than 0. We need to remove this. That is why we need to restrict our inverse function here to be x is greater than or equal to 0. So that, okay, they would really be inverse functions, because what we are discussing here is that they should be inverse function to involve the x here. All right, these points here, let's say I will remove the restriction. The points here are not symmetrical with the graph of the graph here. So therefore, we need to restrict it from x is greater than or equal to 0. That is why, okay, it is right to say that when we find the domain and range of our inverse function, all we need to do is to flip the domain and range of the function itself.